Hello, I'm Dusty Sylvanson, the owner of Strong Timber Craftsman. For the last 15 years, we've been filming content, gathering construction videos and techniques in order to show how we build our homes. Our homes are a mix of traditional frame combined with straw bale and natural building techniques. These particular videos that you're going to watch go through some framing basics and some principles in our method of production. So whether you're an owner builder or learning to build a house or just following along, glad you're here. Welcome to the course. In our last episode, we saw just the foundation wall, and we talked about the different ways to insulate a foundation wall. On this project, we're insulating with 3 inches of extruded polystyrene. It's this blue board made by Dow Chemical. There's pink board made by Owens Corning. There's a number of different products, but this is R5 per inch. So this gives us R15 on the outside of our wall, which is our minimum energy conservation code in this area where we're building. This insulation layer goes all the way down, covering the entire foundation wall. Behind that is an adhesive waterproof membrane that is adhered onto the concrete, onto the foundation wall. So any subsurface water that's pushing against the foundation, there's a waterproof layer so it doesn't get driven through that foundation. We are in a very dry site other than just the regional snow melt that we get seasonally. Otherwise, there isn't a big groundwater charge here either. What we have here is this is Grace Triflex. This is an occlusive layer, and this layer actually ties up underneath our sill plate. It drapes over the foundation wall. So it's over the foundation wall, and we'll show you another shot here where it comes up over and is trapped underneath the mud sill or sill plate. The sill plate is this piece of lumber. Commonly it's pressure treated, and this is the piece of lumber that attaches the framing of the house to the foundation, and all our anchor bolts are countersunk and locked down onto this sill plate. Under that sill plate is some sill seal as an additional capillary break, and then an occlusive layer that wraps underneath. It'll wrap up. The purpose of this layer for us is we're trying something new. We're trying to air seal without the use of spray foam insulations and miles of caulk on the inside. So this layer will actually get wrapped up onto the subfloor and give an air barrier continuous all the way tied in through our air barrier, and we'll catch up more on that as we build this house. You'll see where that air barrier is going to tie into our wall system. This framing system is sitting on the foundation walls, and our floor joists are solid lumber 2x10s. One of the principles on this house is to keep as much synthetics and chemicals out as possible. We do have to use a pressure treated mud sill or sill here for the correct attachment things, but all other lumber on this is just hem fir select structural lumber. It's in a joist hanger, and anywhere this lumber would touch concrete would be a concern. So at the minimum, rather than using chemicals to treat it, we hung this liner here, and this liner drapes over the foundation wall and stops that contact and that wicking moisture into the lumber. And that's what started us with the idea of carrying that all the way underneath the wall and then wrapping it up onto our floor to try to eliminate the air leakage that occurs in here. One of the most common places of air leakage, even in new houses, is at what's called the rim joist, which when a floor is built sitting on the foundation wall, all of the connections and all the horizontal little air channels that are created by that have a tremendous amount of air leakage. And so that's one of our priorities, is really to minimize as much air leakage as we can. So this liner here, where it flops down here, once it's warmer and the house is actually dried in, we'll go ahead and use a high adhesive caulk to that and caulk and seal that to the concrete layer. Over here, this liner is continued, and this liner will wrap up after this floor gets sheeted. We'll wrap up over it and then tuck up into the interior plaster plane of our straw bale wall system. So it's really important that you start your frame square and you start it level. And so no matter what happens with the concrete and the foundation, you can only blame them until you get to this point. At this point, we will shim and adjust and do whatever we have to do to get the floor system as flat and level as we possibly can, and as well as getting the building square, even if that means it doesn't quite sit correctly on the foundation wall. We can use shims, steel shims. There's ways with skirting on the outside and siding that we can adjust if it hangs over just a little bit or hangs under on that foundation wall, but it's our first opportunity to really start right. And so I could not emphasize enough to spend the time and build your floor system square and nice and level, and put everything on the layout. And so whatever your layout is on one wall, your layout should be that way on every wall. And then as you build up, the best way to build is to stack that layout. So the layout of all of these floor joists, our wall studs will lay out exactly like that. In the second floor, the floor joist will be there in the same spot as this layout. And so that really helps us to really establish where layout is, and then we stack the structure on top of it. This also allows us to, on some projects, when we're able to, when an engineer doesn't dictate the spacing of studs, then we can space them out and go to an advanced frame technique of 24 inches on center, and then stack all the studs and stack the rafters or the trusses right on top. So it's just little details that are important. It's a matter of slowing down to make sure you get it as good as you possibly can for framing. That way when you move on, you just use the number. There's no custom cutting in order to correct later on. Start right and start to the number and frame to the number all the way up to the roof. Once we're all square and everything's ready for floor sheeting, then the next thing we do is we lay out where our floor sheeting is going to go. And our floor sheeting, we lay it out all these floor joists on 16 inch on center, which is specified from the structural engineer. And that'll break at 8 feet. So a sheet of plywood will break halfway onto a floor joist. In order to get started, we measure in from the end. Once we are straight and lined and nice and square, we come in from one end, the end that we start on, which on this it'll be the south wall, and we come into the number of where our plywood first sheet will end in order to cover the outside that we intend on covering. And so typically we'd come in from a rim joist about 48 inches and snap a line right there. You can come a little bit more, go to 48 1/8, and then your plywood's not hanging over. It's a pretty good idea. And then snap that line, and then as we sheet, we follow this line. And we'll move the joist to where layout needs to be, because lumber will curl, it'll wave and things like that. So we want to go ahead and make sure we stay straight and we stay on layout throughout the entire process. Thanks for watching. The next video is linked here on the screen. If you'd like to follow along this house building process, please consider subscribing. Wishing you well on your journey, whatever you're about to go build. Take good care.